now here is the why. Why are we dealing with maximum and minimum values of parabolas? Well, the reason is because one very important thing that a parabola can model is how things fly, how things move when acted upon by gravity on Earth. So this example deals with throwing a baseball, right? And so I want you to think about what it looks like when you throw something. So when you throw something, let's say I take something and I shoot it, or I shoot it out of a cannon, right? So here's my cannon, right? And I shoot it, and what's going to happen is it's going to go up, it's going to start to flatten out, and then as soon as it's done flattening out, it's going to start to come down, right? And then it's going to, hit the ground, right? And so that is how things fly, and they call that a parabolic trajectory, right? Parabolic trajectory, the word parabola is in parabolic, so that's where it comes from, right? So this is a slightly different case of that, but it's the same idea, and it's because we're dealing with gravity and something that we're throwing in flight, it's going to follow a parabolic trajectory. It's not going to look like that when we throw it up because this person's standing still and throwing it straight up, but if we graph it, it's going to model that. Okay, so it says, explain why the function has a maximum value. Well, think about how something flies. So I'm going to be standing here, right? This is me, right? And then I'm going to throw the baseball up, right? And it's going to go up, 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 up. It's going to stop eventually at a point, and then it's going to come back down, and it will pass my arm, and it will land on the ground where it will stop. Okay? So the function has a maximum value, right? Because it represents the top of the parabola there. So think about how we know about how things open. Well, I know that this parabola opens down. And the reason I know it opens down is because A is less than 0. A is less than 0, so the parabola opens downward, all right? So therefore, and I'm going to use IE, we have a maximum value, right? That's why we have a maximum value. This thing opens down, right? But I mean, if you just look at the picture, right, you can see that it's going to be a maximum value, right? Not a minimum, right? This thing isn't just going to go indefinitely up, right? It has to come back down because we're talking about something on Earth, right, where we're throwing something and gravity is acting upon it. All right, now when we talk about when will the baseball reach its maximum height, well, it will reach its maximum height, and that's where we got to look at the equation. It says the height h of a baseball in feet after it is thrown straight up t seconds, right, after it is released is given by the function. So this is going to be the point t seconds when we are at the height of our parabola. So we're going to have something that looks like this, right? Our parabola on a graph, right? And this point is going to be my maximum, right? My maximum value. That is the worst axis of symmetry probably ever drawn, right? But that is, believe it or not, that's my axis of symmetry, right? So on a graph, if I'm graphing this, right, that's going to be my x value. So that's my x value. It's my axis of symmetry. And that's going to be where my maximum height is. So let's find that. All right, so we have x equals negative b over 2a. We have negative, my b is 30, and then 2 times my a is negative 16. Well, we're going to get negative 30 over negative 32. My negatives are going to cancel each other out, right? Negative divided by negative is positive. And remember, when you're talking about fractions, you're always talking about a division problem. And you get 15 divided by 16, which is the 0.9375. Okay, so that's what you get when you divide 15 and 16. Remember, when you divide numbers, you just take the numerator and divide it by the denominator. So that's when. So we will say 0.9375 seconds. That is when it's reaching its maximum height. So not throwing this very hard if it's only flying for less than a second, right? Now, what is the baseball's maximum height? That is going to be the y-coordinate. That is the y-coordinate of my vertex, which is right there. Okay? So what I do now is I take this and I find my y-coordinate, my vertex, the way we have been with everything else. So we're going to have h, so my function of 0.9375 seconds, right, is going to be equal to this with this whole mess thrown in here, right? 0.9375 squared plus 30 times 0.9375 plus 5. Okay, and so let's figure this out really quick. I hate doing things like this, but you know, that's how it goes. All right, so we got 16 times 0.9375 times 0.9375, and that is going to give me, and I'm going to make this negative, right, because we have a negative times that. We have negative 14.0625, and then plus, and we're going to figure this guy out, 30 times 0.9375 equals 28.125, and then plus 5. All right, so I am going to I'm going to add all this up, so I'm going to do the positives first. I'm going to go 28.125 plus 5 equals 33.125, and then I'm going to subtract 14.0625, and that is going to give me this lovely number of 19.0625 feet, right? And then so for our purposes, right, we are going to say this is about 19.1 feet, right? So we'll just round that up, okay? So that's why these things are kind of useful, right? Is you can actually, if you kind of know how much you're modeling and throwing something up, you can actually predict how high it's going to go. You know, and there's a whole series of physics, you know, devoted to this with like velocity and all of that, and maybe some of you have had experience with this, but it all starts with these quadratic equations, right? And the fact that they actually can model very useful things. So I hope this was helpful to you. Very fascinating stuff. There is definitely a lot of computation involved with this and a lot of areas to go wrong, so just make sure you're keeping an eye on your negatives, your integers and everything with that, and how you're doing that. Use a calculator if you're sloppy at it. That's okay. And good luck with everything. All right? Thanks.